Happy Monday, guys. Good morning. How are we? Oh, I guess I should give you guys rights to type to me. There we go. Hello. How is everyone doing this morning? Good morning, Caitlin. Yeah. Like the positivity. Good morning, morning. Got a little bit of accent going on your typing, Caitlin B. That's great. I know. This weekend was super fast. I don't know about you guys, but it was like, whew, okay, it is now Sunday night, and yeah, it's kind of crazy, but it was good. I had a super weekend on Saturday. Normally I get like some kind of pedicure thing in the summer, but because the summer we had 2 family reunions, which were all outside, kind of camping kind of thing. We were moving, so it was just like a gong show. My husband's parents live in Williams Lake, so they stayed with us for 2 weeks. And then we were gone to Disneyland for a week, and then we had the actual move and all this stuff. And so the idea of even trying to like do anything was just crazy. So, and then we've been renovating since we've gotten to our new place. So I finally said, okay, now I can go. So it was so nice. My friend and I, we went and did that. We had lunch, we went shopping and had that all good. And then we went and saw Thor. Oh my gosh, you guys. If you have not seen Thor, it is so funny. Someone told me that it was the best Marvel movie they've seen, and now I know why, because it was hilarious. I'm not going to tell you anything about it because it ruins it, but it was a really, really funny movie. Yeah, Jess, I think you mentioned you loved it too. So it was so good. So definitely go and see it. How about you guys? How was your weekends? What are some things that you guys ended up doing, or anything you want to share? Love to hear what you guys did when you're away from me. I only saw you guys for like an hour and a half last week. Miss you guys. Oh, like really sick or just like sick? How was that, Belle? Just sick? Oh, that's too bad. Oh, you went to, who were they playing? Because remind me where you're at again. Where are you, Jess? I can't remember what state you're with your dad. I can't remember what state you're in. It was really good? Oh, good. Rams and the Vikings. Oh, was it? Okay. So Jess, where are you? Because now that doesn't help me. I can't remember. You're in Minnesota. Okay. Yeah. Did the Vikings win? I don't know. I didn't watch the game, but did the Vikings win, Jess? Ah, there you go. So that's a good game to go see. You get to see them beat them. That's awesome. Good. Anybody else have anything going on? Dean, are you feeling better now? You've been sick for a while there, so I'm making sure you're feeling okay. How is everyone else doing? 24-7. Oh, that was a pretty good game. Good. That's good, Dean. I want to be in the snow, but I think there's no more snow here. It's all like up in the higher, like Big White and Coquihalla. There's no snow down here anymore. So good. That's good to hear. Awesome. All right. So, oh my gosh. Okay. I got to tell you something else. Total squirrel moment. I just got to do this. So about a year ago, so I have a guy that does all my computer. He builds my computer and does my tower and everything. And so I was getting to the point where I had very little memory left, and I said, I need some more. And he goes, well, it's been a while since we've fixed up your computer and upgraded it. Why don't we do that at the same time? I'm like, yeah, sure. It's been needed. I think it was at least 5 years since the last time we did it. So he takes my tower, and I was just using my laptop in the meantime. And so up to this point, he was working out of his house. Like, he had his little office downstairs, and he was super busy, like super, super busy, but that's what he was doing. So he finally decided that he wanted to get a place downtown. So he got an office downtown, and so he was just kind of slowly making his way into the office. And so he thought, I'll just bring my stuff over. And so he brought my stuff over, and he had my new hard drive, which I can't even remember how many terabytes it was or whatever. And he had my old hard drive hooked up, and he had my new one hooked up, and he was transferring the information. And so he started that at night, and then he left and went home. And so the next morning when he got there, he was broken into. And they stole my brand new hard drive. And so he phones me up, and I said, he goes, yeah, I got broken into. And I'm like, so what happened? He goes, well, they took your new hard drive. And so then I looked at him and I said, so was my data on there? And he goes, I think so. He goes, because I had it transferring the night before, and it should have been done by that morning. I'm like, oh my gosh. Everything was on there, like every possible picture I've ever had, and every piece of information from school. And I had another job going on the side that I was doing. Everything was on there. I'm like, oh my gosh. And personal stuff, right? So I was like, oh my goodness. And I said, what else got taken? He goes, it was just my stuff. He said, he goes, yours was my only client stuff that was in there. I'm like, oh, awesome, yay. And so he goes, they stole a couple of his hard drives, but he goes, this is the weird part. He goes, they took some food that was above his fridge, like there was some nuts or something like that. They took some blankets. They wrecked almost a ton of equipment and stuff. He goes, and then they took a couple, your hard drive and some other hard drives. He goes, but they didn't take like the brand new laptop that was in an actual box. They didn't take something that was worth more than what they actually grabbed. He goes, I don't think they knew what they were doing. He says, I think they could have been like maybe some kind of homeless person needing food and the blanket and all that stuff, but just looking for something quickly to do. So he filed a claim and everything. So I said, well, you still have my old hard drive, right? So we can just take my information off the old hard drive and put it on, we'll just have to get a new one, insurance will cover it. And he goes, well, they kind of wrecked your old hard drive. And I was just like, I have no more information. He's like, yeah, it's all gone. Like your whole tower is destroyed. And I'm like, oh my gosh. But luckily, I have an external, so I have a backup drive through him, right? And so he goes to me, he goes, can I get the backup drive from you? I'm like, sure, no problem. So I give him the backup drive, and he goes, he phones me a couple of days later, and he goes, how long has it been clicking? And I said, it only clicked once that I know of. Brian, my husband, said that it did it one night, and that was it. And then I heard it one morning, went in, turned it off, turned it back on, and it stopped clicking. So I assumed it was fine. And he goes, yeah, that clicking means it's not working. It means that there is a glitch and it hasn't, so whenever it started clicking, it hasn't been backing up. And I'm like, oh my gosh. So he goes, I'm taking this to a specialist guy that knows how to take things off of those backup drives. And so he sends it to this guy, which I can't even remember how much I think it was $1,000 to get this guy to look at this thing. And so the guy looks at it and he goes, I can't get anything off it. It is so wrecked. I can't get anything. And so I'm like, okay, so I've lost my new hard drive with my information on. My old hard drive is gone and my backup drive is done. And luckily, I have my own backup drive that I keep. I have a fireproof box and waterproof box that's where my not visa, passport and stuff is, and all those, my will and my mom's will and all that kind of stuff is in there, and I keep that in there. But I only backed up a month earlier. I hadn't backed up recently, so I actually lost some things. I lost some pictures that were on my hard drive, on my desktop, and all my programs were lost. We had to get those back. And the thing is, some of those programs you can't get back anymore. So I was kind of, you had them and it works, but then once it's gone, you can't get it back again. So that was a little frustrating. So we worked with it. I changed all my passwords on every single possible thing I could think of. So I get a call last week on Wednesday. Like, get this. So I get this call, and it's on my cell phone. It says no caller ID or whatever. I'm like, ugh. So I answer it, and this guy goes, hi, this is Constable Eric, blah, 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 and from going on. And there's a lot of scams going out there right now. So I was like, oh, is this a scam? Is it not a scam? So as he started talking, I'm like, no, this sounds legit. So he tells me, he goes, I'm looking at a hard drive that has a lot of pictures of you. And my first thought is that someone stole pictures from me. Someone went on my Facebook page or something and had a whole bunch of pictures and has them on the drive. And I'm like, kind of confused for a second. And then I went, oh my gosh. I said, do you have my hard drive? He's like, yep. He goes, we busted a guy and found a whole bunch of stolen stuff, and one of these things was a hard drive. And he goes, who made your wedding PowerPoint? And I said, I did. He goes, it was awesome. He goes, but he had to watch my wedding PowerPoint because he didn't know whose hard drive it was, right? It's not like it's labeled Miss Makowetsky or whatever. So he had to watch my PowerPoint, my wedding PowerPoint, and then at the very end it says congratulations to my husband and I, and has our names and last name and everything. And that's how he found who I was. So it was so crazy. And so I said, what happens now? And well, I told him that there's a claim already open from my buddy, right? So he said, okay. So I gave him his phone number to contact him so they can meld the two things together. And yeah, there was a lot of people on there. There was a lot of people, but it's obvious who the two people were about. So then I said, now what? He goes, well, we're building a case against this guy, so we're going to probably have to use your hard drive as evidence. He goes, but either way, if we need it or don't need it, you're going to get it back. And I'm like, oh my gosh. I know, it was so crazy. I thought it was like gone. Like I thought, because in order to look at the stuff on the hard drive, you have to be able to connect it into an actual tower, into a computer, right? And the people that normally steal that stuff, if they were taking blankets and food, it kind of doesn't seem like they would be someone that has a tower to plug into. So I don't know if the guy that they got my hard drive from had gotten it from somebody else. It was passed on a few times or anything, but yeah, so then I'm going, why is he holding on to my hard drive? Like, it's been a year. So it's been quite a while that someone's had it and it's been passed on. So it's a little freaky. I was like, holy cow. It was crazy. I thought I'd never see that again, and I thought it was all gone. So it's really good because I have a lot of stuff on there that was not saved on my other backup. So yeah, so it's good. Yeah, that's what I thought too. So I'm amazed they didn't wipe it already or do any of that stuff. So it was crazy. So I had to tell you that. That's my story. Okay, that was my squirrel moment for today. Okay, awesome. Yeah, yeah, there's some interesting stuff going on. So yeah, it's cool. So all right, so I thought this was kind of cool. I do algebra, I do trig, and I do statistics. Graphing is where I draw the line. You guys get it? Draw the line, graphing. Guess what we're doing now? We're doing stuff like that. Yeah. So what's really cool is that term 1 was some of the harder stuff. So we have a lot of that out of the way, and it's kind of like, whoo, you get the gross stuff done, and then you get to do sort of the a little bit more chill stuff. So, but this, like I said last time to you guys, we're going to go, it's a little bit of a faster pace. The units aren't overly big. So it's going to be quicker in terms of the length of time to do the unit because the content's not so major, but it's not as hard. So yeah, so it's going to be good. Okay. So coming up for you guys is you have Bumbleshoot Theatre tomorrow. You have fencing. How many of you guys did the fencing on Friday? How many of you guys went fencing? Because that's cool, Belle. That's awesome. How was it? Did you have fun? Anyone else do the fencing? You think you're the only one? Okay, yeah. So, and then we have, the pottery. So Mr. Fender had, the pottery was all fired and all finished and glazed and everything. And so he brought all the pottery in from the last session. Oh my gosh, they're so cool. There's some really, really good pieces of art that people have completed, so it's really neat. So if you guys get to go to the pottery making again, I think you got to make 2 things, something like that, so it's really awesome. Yeah. So Bumbleshoot, you got fencing coming up, and then the following week is the pottery, art gallery, and archery as usual, which you guys have had a few sessions of that, which is really cool. All right. So today we're going to start a new unit. It's the relations and functions. You guys have, I know some people already taken the test because I said you guys technically can start taking it when you want, but it's officially opening today. So you have till Friday to take the trig test, and then you'll just have some worksheets to do. So yeah, so let's get to the nitty gritty. All right, so have your note paper out. I would really encourage you to make sure that it's just a reminder, because I don't see you guys physically in front of me with your paper and your binders and everything. I assume that you guys have some kind of organizational system going, but I just want to sort of remind you that your brain, it has a lot of stuff right now. All of your senses are feeding it information, and it needs to deal with it. It has to cipher through it, it has to file things, it has to discard things, it decides what to pay really close attention to, what not to, that sort of stuff. And the more you can help your brain do that, the better it works for your memory. And one of the things you can do to help your brain is be organized. And when you have your notes organized, your papers organized, that really helps your brain to retain the information that you want to retain it, and it's easier for your brain to access it later. So what I would really hope most of you guys have is a binder somewhat system going on, and you can do it unit by unit. So you can have the exponents unit, you can have the polynomial unit, you can have trig unit, and now this one could be relations and functions unit. I would suggest probably organizing somehow like that. So, and then have the papers in there and have some kind of order within there, because that if you're disorganized in your papers in your binder, your brain doesn't naturally sort through that. You have to teach your brain to sort it, and so you want to make sure that you are helping out as much as possible. So, and that's a good tip, especially for tests when your brain is trying to find that information. It can't find it if it's all over the place, right? So just a suggestion, like I said, I don't see you guys physically when I'm actually in a classroom teaching and can see your binder, but some of you guys, that would be a really good thing for you to do, okay? So you should have some notes going, ready to go, some paper to start the relations and functions section. Before we get going, sorry, I have a sticky note to remind me of something. A lot of you guys, I don't know if this is because you think this is what I want or if this is just kind of what you're choosing to do. I know, Alexis, it was fun. But some of you guys are just handing in a piece of paper with the typed answers on, or you're taking the original worksheet that I gave you and just typing the answers in or writing the answers in. I don't care, if it's a piece of paper that does not look like the original one that I gave you. I think one of the most important parts for me to see is your work that you're doing on there. So a lot of you are just giving me the answers, and if you're getting them all right, then that's fine. But if there is one mistake or anything else, I cannot help you. I cannot see what you did. If it's a silly math error, that totally changes how I look at what you did on that question versus if you're not understanding the difference between sine and tangent or something like that. So please try, I'm really encouraging you guys, if you could please start just hand the work in. So if you take if this is your method, if you have a blank piece of paper, you do question 1, you do the work, you get the answer. You do question number 2, you do the work, you get the answer. Hand that in. Circle your answer and hand that in. I don't need to see it on the other piece of paper. I'm smart enough to figure out what question you did, as long as you're numbering it. So I would really suggest some of you guys doing that. Also, circle your answers, guys. A lot of you are doing so much work on these questions, which is great, but then you expect me to find the answer and assume that I know you know what the answer is on there. I'm going to stop assuming. So from now on, if there's a whole bunch of work going on, circle the answer, because that's what I'm going to look at. And because you might have thought this was the answer, and I went, oh, there's the answer over there, and you're like, whoo, lucky Miss Mac saw that, because I was thinking it was this one. So I need you to start circling your answers. Not circled, and there's lots of work, I'll just kind of go, sorry, there's no answer here, okay? So just make sure you're doing that. So any questions on that, what I'm saying there? Sorry, there's 2 people who messaged me, I'll have to get to that in a bit, but any questions on that? Have you guys seen my Olaf cup? Look, his face turns. It's fun. He's so cute. Okay. All right, so I'm assuming everyone's good with that. Okay. So first thing first, reading a graph. Sorry, I have to use my notes here. I got a whole bunch of stuff going on here, so I'll be flipping paper back and forth. Okay, so reading a graph. That's part of this unit. It's a very minimal part, is be able to read a graph, because that is something that you would have done a while ago. So what I want you to do is look at this, and at the bottom, does anyone remember what axis this is? What axis is this called? It's called relations and functions. Jocelyn, relation and functions. Does anyone remember what that bottom? Yes, that's the x-axis, and this one right here is the y. So whatever happens on the x will affect what happens on the y, okay? So, so what we're going to do is look at what's happening with these lines. So what's happening is we have some time happening. We have 1 hour, 2 hours, 3 hours, 4 hours. Sounds good. All the way to 10 hours. And then this is the amount of kilometers that they're actually going. So we have someone starting at 0, 0, which is at the very corner. So they haven't moved. They're just freshly starting, and they haven't gone anywhere. No, don't worry about drawing it. You can kind of, you can, if you want to do a quick sketch, you can. So the trip starts. So this person is going from Comox to Nanaimo, and they go from point A to point B. So what happens here is that if you were to describe this, I'm not going to go too much into detail, you would say from A to B, let's get my pen going, A to B, it's goes up to the right, and I'm just going to abbreviate up to the R, I'm not going to write the whole word out. And then you can say that time increases, and I'm going to put a little arrow, which kind of would be abbreviation for increases. You can write the whole word down if you want. And distance between Comox and Nanaimo is getting less now. So distance decreases in order to get to Nanaimo. So it's kind of weird to think it that way, but that's what actually is happening, because from the point A to the final spot is a huge amount of space, but now we moved up, so there is less distance for them to go, okay? So then we got to describe this. So that's just looking at the graph and literally looking at the graph and saying what actually happened, okay? So now what we want to do is kind of think about the person and the drive and what they're doing. What actually happened from point A to B? What happened there? So for example, this one, I'm going to change the color. How long did they travel for? How long was this traveling time from point A to B? Yeah, so they traveled 2 hours. Okay, so that's what part of the thing happened. And how far did they go in those 2 hours? How far did they travel? They went 30 kilometers. Okay? So that is looking more specific at the graph and taking the information from what it's actually representing. Now we got the weird one. We got a B to C. What do you guys think? So B to C, we can say it was horizontal. It was a horizontal line. The time, did anything happen to the time, or did time stand still during B to C? What happened to B to C? Did time stand still, or what happened to it? Yeah, so time was 2 hours there, okay? Or we can just actually say, sorry, I'm going to erase that. I'm going to say time increased. We're not doing specifics quite yet. And what about distance? What happened to distance? Increase, decrease. What happened to distance? Did we decrease distance? Did we go from 30 kilometers? Did we go less than 30 kilometers? Yeah, it stayed the same. Good. So distance stayed the same. So then we actually look at the graph and go, okay, what possibly could have happened here? So time passed. It went from 2 hours to 4 hours. So we have 2 hour time spot, but we went nowhere. What possibly did these people do? This is their trip, yeah. So trip, so we can say that they had a pit stop, I like your word, pit stop for 2 hours. Okay? So this is just an example of reading the map. Then you can look at C to D, do the same thing, saying they traveled for what, an hour there, but they went a long distance in that hour. They were driving very fast. And so they went, what did they go, 70 kilometers in an hour. So that's insane. And then we can see that D to E, that they did another stop, and that was another about 2 hours there. Another 2 hour time slot. And then why is it going down? Sorry, give me 2 seconds. Yeah, so why is it going down now? What's happening there? So let's look at E to F. What's happening there? Why is it going down? So it's going down to the right. What's happening to the time? Did time increase? Yeah, so distance. Okay, so distance decrease. What happened to time? What happened to time there, guys? So look at where they were at E, and then look at where they were at F, and then tell me what happened to the time. Did it decrease? Did it increase? Did it stay the same? Yeah, in a second, Lindsay. Just give me a sec, hon. So what happened to time there? What did it do from E to F? Yeah, it increased. Okay, so from E to F, it actually did increase. Okay, I'm just going to go back for Lindsay. So don't overly stress about this too much. Yes, they did take a lot of pit stops, but look, they traveled for 10 hours though. Like that, you need to take some pit stops, but they're really long. That's the thing about the pit stops, they're long ones. A lot of people do take about 2-3 pit stops in 10 hours, but they're 2 hours and 2 hours, and that's crazy. Perfect, thanks, Linz. Okay, so then what happened in E to F now? So let's look at the actual graph and figure out, not talking about general terms of distance increasing, decreasing, and time and stuff. So what actually happened there? Kind of interesting, like it's showing that their kilometers are losing kilometers. So what kind of happened there? Why would they be losing kilometers? What's happening in the trip? Yeah, so AB, the distance did not decrease. AB, the distance increased. From A to B, the distance increased. They went from 0 kilometers to 30, so it increased. But why is E and F? Actually, what is happening, thanks Caitlin, it's decreasing, but why is it decreasing? Because this was their destination here. This whole area, this is Nanaimo. They made it to Nanaimo. So now because we're losing distance, what we're actually doing is going back. Okay, so we're going back to Comox is what's happening. And so this is just, I know a lot of you guys are like, well, why is the arrow not going back there? Because it's not a map. This is not a map where you show an arrow going from point A to point B, and then back again. It's not a map. This is a graph showing a relationship of time to distance. And so because we're showing a change of time, we have to show it over here. We have to show it on this side because this is where the time is. So at the 7 hour point, that is when they decide to go on the return trip, which is then showing this decrease of time here. Okay? I know. Maybe they came to pick up a dog. Maybe they came to get a little puppy. Yeah, so maybe they're dropping someone off in Nanaimo. Maybe there's a college there. They're dropping their kid off or something like that. All right, so basically what I wanted to show is how you can use a graph such as this in order to show what you would normally show on a map, how you read this, and how you can get a general reading. The map goes, or the graph, the line goes to the right, this is decreasing, this is increasing, but then you have to read the story and understand what's actually happening. So what happened here? They drove to this point, this long, they did a pit stop for 2 hours, they sped and went way too fast, and in an hour they made it to their destination. They stayed there for 2 hours, and then they started coming back, had another pit stop, and then they came back again. So it's looking at the graph and seeing what the story is behind what's happening. So yeah, I don't want to spend a ton more time on that, but I do need to make sure you understand those things. All right. All right, are we good doing that? Oh no, I'm going to do one here actually. I'm going to get you to draw this one. Sorry, I just realized I'm going to get you to do this. Okay, I'm not going to make you write this out. You don't have to write this out, but what I am going to get you to do is draw what you think the graph would look like. Okay, so I'm going to actually, this is a little low. I'm going to move it up a bit so I have a little more space. So, Michaela is listening to music on the radio. After 4 minutes, her sister, Aaliyah, walks into the room and asks her a question. She turns down the volume slightly and answers the question. Then she turns the volume back up to the same as it was before. 3 minutes later, her mother turns on the vacuum, so Michaela turns up the volume. After 4 more minutes, the news comes on the radio and she mutes the music. So I want you to sketch, so just like we sketched the travel time of how many hours they did. So for 1 hour they drove here, then they did a pit stop, and this is how many kilometers they went, and that kind of thing. You're going to do the same thing here, but you're going to relate the volume level and time. So let's have someone tell me. I'm going to get you to do this on your own in a second, but I want to make sure we are drawing our graph correctly. So what would be the x value? What's going to be the thing that affects the other part? Or if you know what the y is, let me know what the x or y is. Just let me know what you think. Just take a guess. No worries getting it wrong. It's all good. Who knows or would like to take a stab at what you think the x or the y axes would be? What would it be labeled? Good. So time. Which one, Jocelyn, do you think is time? Do you think that? And the volume. Y is volume. Good. So then time. Good. So I want you to label volume here. And then you're going to put time down here. Sorry, that is low on your screen, but okay. So what I want you to do is take the information and some of the color, there's some color coding that I've done there for you. What I want you to do is, you don't have to be perfectly precise. especially because they did not tell us the volume levels, but you can sort of just pick a spot and make it and go up and down from that spot. They have given you time with some minutes. So what I want you to do is see if you can draw out what this would look like, similar to what we did with the kilometers and the time of the guy traveling, okay? So I'm going to give you guys about, I'll give you 2 minutes here, and you guys can look at the information and figure out how to best draw that, okay? So 2 minutes, and I'll see you guys in a sec. Everything end okay with the one guy there, Mike Shaw, on Thursday? Good. Okay, so hopefully that was enough time for you guys. So we're going to look at the information and we're going to listen to the radio. So where you decide to have her volume level is totally fine. So I'm just going to have it coming from the middle. So she's listening to music after 4 minutes. So at some point, I'm going to have to put a 4 here to indicate that it's 4 minutes. At 4 minutes, her sister comes in and asks her a question. She turns it down. It says slightly. So we're going to just make it go down just a little bit. Okay, so during that time, she has it off. So, oops, sorry, I got to make it angled just a little bit. So we have to make it angled just a bit because it says she just comes in for a second or so. She turns it down slightly and her sister leaves just to ask a question. So it's not much time. So it's going to be a slight angle that comes down like this. Okay, and then she turns it down, and then for that slight little bit of moment that her sister's asking her a question, the volume's down. Okay, so here is her turning the volume down. This is her turning the volume down, and it's not going to be like immediate. She's probably just doing something like this. So that's why it's at a slight angle. It takes a couple seconds for her to turn it down, and it's a progressive decrease of volume. Then we have this guy right here is how long that she's talking to her sister at that less volume, okay? So it says that she asks her sister, she turns the volume down slightly, answers the question, and she turns the volume back as it was before. So again, she's not going to crank it up. She's going to do a slow increase, and now she's back to where she was, okay? So it says that she turned her volume back up to where she was, and then she says 3 minutes later. Okay, so you can decide, I guess here, if you want, you can say that was 30 seconds, you can say it's a minute, it's up to you. It's not a stressful piece because they don't tell you how long she talked to her sister. So you can just say, let's say she talked to her sister for a minute. 3 minutes later, so she's listening at this volume, 3 minutes later, which would be roughly around 8, if you put 7, that's totally fine, or you put 7:30, that's totally fine as well. All of a sudden she turns the volume, 3 minutes later her mom turns on the vacuum, so she turns the volume up. So we have to have the volume going up now. So she turns the volume up, She listens to it, and after 4 more minutes, so we're looking at about 12 minutes, you can have 11, you can have 11:30, whatever. After that, she hears the news coming on, and then she mutes it, so basically there is no volume coming out, and it goes down to nothing, because mute is just basically probably a button or something like that, so it's like an immediate loss of volume versus her slowly turning it down. So this is just a rough kind of way of portraying a situation that happened. And you can do that with a lot of things. When volume or the amount of time affects the volume level and what's happening, you can take any kind of circumstance and put it into a graph. Yeah, okay. So hopefully you guys had something similar to that. And like I said, there is some differences that you could have had, which is totally fine. If your time is off a little bit than what mine is, that's not a big deal. If your volume level, you have it at different spots, as long as it looks roughly like this, as long as it goes flat, here, 1 second. As long as it goes flat, down, flat, up, flat, down, as long as it looks like that, if yours is way higher on your graph than mine, it doesn't matter. So that's totally good. All right, any questions on the drawing there? Okay, all right, so now we're going to look at something called relations, and we're going to just do a little bit of writing here. So a relation, actually, I'm going to type it. I'm going to type it for you guys, and I'm going to make the lettering a little bit bigger here for you. Oops, I'm going to actually make it bigger. Okay, relation. It connects the elements of one set with the elements of another set. Okay, so you're going, okay, there's a lot of words in there. I don't even know what you're talking about, Ms. Mac. I'm just going to explain what those mean. Give you a few seconds to write that down, because I can type probably faster than you can write. So relation is basically, it connects a set of something with a set of something else. That is basically what a relation is. So a set is just a collection of specific, they use a different word, I'm just going to use specific objects. Okay? And then when we say element is an object in the set. So this is very official jargon. You can use whatever language you need to use to make this make more sense to you. So you can say it is comparing a group of something with a group of something else, and within that group are these individual things. So I can compare a group of apples, a group of oranges, so that would be a set of apples, a set of oranges, and then the element is an apple, the element is an orange. So it's just using fancy lingo in order to get you to understand that. Okay. So how these are shown, these are usually shown in an ordered pair. And you guys should know what these are, because this, oops, that's not the right letter. You should know what these are because you've been using them, I think, since at least grade 7 under graphing in ordered pairs. So they're usually shown with X, Y, and in brackets. That's usually an ordered pair. So in this case, it means element, oops, in set 1 and element, oops, element in set 2. So that's really what it is. It's just that relationship between those two. Okay. So one example, and again, like I said, this is using language that you don't necessarily have to use, but you should know what it is if they do bring it up in some kind of exercise activity next year or something like that. But it's just basically a group of something, comparing it. So what I'm going to say is, I'm going to do Surrey is in the province of BC. So I'm just going to write that in. And then I'm going to show you kind of specifically what it's talking about when we're talking about this, the ordered pair and the set and the element and stuff like that. So I'll give you a second to do that. You guys doing okay with timing? Am I going okay? You guys are so quiet. Are you there? So quiet. Oh, Emily's alive. Emily's alive. Yay! I see her typing. Okay. Are you guys with me? Give me some check marks. You guys with me? Come on. Check marks. Are you guys ready? Yeah, there we go. Okay, good. Awesome. So what this is an element. That's an element. That's like a chunk of something, okay? This is the first set. And then over here, we have an element in the second set. Okay? And this guy here, can someone tell me, so if you look back at the definition of what a relationship is, it's this element and this element. So we have two sets of elements going on here. What's that part in the middle? What is that? The part that says is in the province of. What would that be? What would that be? It starts with the letter C. And it's also in the definition of what a relation is. Close to collection. Good. Thank you for trying. What would be another guess? Yeah, thank good. It is the connection. So in order to connect Surrey and BC, there has to be some kind of connection between the two, and the connection is there. It's in the province of, right? So that's the example of that. And if we were to make this into an ordered pair, I would put the first element set here, and I would put the second element set there. So what I'm doing here is just trying to show you how math doesn't always have to involve numbers, and that's what I was also showing you with the graph. Even though there were numbers involved in it, but it's also looking at the story behind things, and you can actually use words in other situations about things to put together in some kind of relationship. And that's what's happening with this part of it. So here I'm showing the relationship between Surrey and BC, and the connective piece is that it's in the province of BC, and that's what connects Surrey and BC together. Okay? Perfect. All right. Okay, are we good there? Hopefully you guys got that down. Okay, so just a couple reminders here. Does anyone remember what the independent variable is? Does anyone remember? Do you need me to go back, Belle? Okay. So while we're doing that, so you guys saw what the next part is. So I want you guys to try to think, what is the independent variable and what is the dependent variable? That is going to have a little bit of an effect on when you're doing the graphing. Okay? All right, Belle, just let me know when you're ready to go. And if you can take a picture of the screen too. And then you can just catch up in a second. What, Jocelyn? What? Should I guess? You're a mermaid. Did I guess right? No? Okay, you're welcome. What, Jocelyn? You got me all interested. Oh, that's cool. That's awesome. You're going to be nice and warm like Caitlin and Sean are, make us all jealous. That's not fair. That's awesome. That's good. Okay. Independent variable. Does someone have just a quick little, doesn't have to be official definition of what the independent variable is or the dependent? Does anyone know what those are? It is not a dog. No, independent variable is not a dog. All right, focus back. Focus back. Focus. Okay. Independent variable. So what is that, or what is a dependent variable? You're saying what a variable could be. A dog? Anything could, yes, it could be anything. What is the definition of it though? I don't want examples. So Caitlin, focus, focus. Okay, what is independent variable, dependent variable? I'm not giving you guys the answers. You guys should know these. What are independent, dependent variables? What are they? What is the meaning of it? Variable is dependent, yes. So always try not to use the word in the definition. So if I say, what is a chair? Don't say a chair is is the chair over in the corner. That doesn't give me a definition of what it is. Running is when you run from one spot to another. That doesn't tell me what running is. So try to see if you can come up with a definition of it without using the word in it. Okay, thank you. Okay, so what I'm going to do, I'm going to give you guys a reminder. We're struggling here a little bit. Independent variable is what... Oh, I got capitals going on here. I got to change, wait a second, make my box bigger. There we go. What we are changing, that's basically what is a really basic definition. It's what's changing. So we're changing the amount of jelly beans we put in the jar, and how does that affect the fullness of the jar? Or we are putting 5 Mentos in pop, how does that affect the spray, kind of thing, right? So independent variable is the thing that we're changing. So then after kind of hearing my example, what I said there, what do you think the dependent variable is then? So the independent thing is what we're changing, and someone said it kind of depends, the dependent one depends on the independent one. So what would that be? There's really one word you can use. Stays the same. That, oh, good. No, that's a control variable, Alexis. Good. You remembered something from that. That's good. So yeah, the one that stays the same is called a control variable. So that's if I'm doing the Mentos and Coke lab, I would make sure the bottle stays the same, and the method that I put the Mentos in there and the type of Mentos I put in there all has to stay the same. Those are control variables to make sure the experiment's fair. But what is the dependent? It starts with an R and it's really one word. So if I put one experiment, I put 2 Mentos in. The other experiment, I put 4 Mentos in. The other one, I put 6 Mentos into the pop. I'm changing the number of Mentos, and I want to see reoccurring. Nice try. You guys got this. RES. You guys got this. Yeah, it's the results. Okay, it's what happens. Okay, so that's what this is. And so when we were looking at the time, what happened during that time is how far they went. What happened in that time depended on what happened to the volume. Okay, so thanks. It is the results. So that's just a reminder. So when it gets to the point where you're trying to decide what goes on the x-axis and y-axis, the independent variable goes onto the x-axis. On x-axis. And this one goes on the y-axis typically. Okay, so that's going to help you guys when we get going into the actual graphing section of it. Okay, give me 2 seconds. I got to see what my graph is. Okay. Okay. So with this, so when we're talking about a relation, okay, let's trying to remember what I meant by what I'm going to show you here. So when we have a graph, like so, reminders, we need to have arrows at the end of the axes. So you need to have arrows. That's an A. And you need to label the axes. So the horizontal one, what is that one? Is that the x-axis or the y-axis? Which one is that? The horizontal. Nice try, Belle. We're going to go with the opposite. It is the x. So the horizontal is the x. Thanks for trying, Belle. And this one is the y. So you got to label the axes as well. Okay. And, and these are actually little mini number lines. So this is always going to be 0, 0, and then going this direction is a number line, and going this direction is also a number line. So this, you can go up by 5s if you want. So this can be 5, 10, 15, 20, 25. On this side, it would be -5, -10, -15, whatever you decide to do. But the important thing is when you're drawing a graph, that number line, the x-axis, What you do on one side has to match the other. I cannot make this a 2, -2. If I'm going by 5s, each notch is a 5, then I have to do that on this side. It's the same number line. I can't go and change it. Okay? So I have to make sure that I have consistency on my x1. That being said, the y-axis is its own number line. Okay? And because it's its own number line, it doesn't have to do the same thing the x is doing. So the x right now is going by 5s. This guy, I can do 10s, 10, 20, 30, 40, whatever I want to do. And then on the bottom, I have to do the exact same thing. I'm just going to erase that -2 there. I have to do the exact same thing. So this is going to be -10, -20, -30. Okay? So just a reminder of how to set up your graph. You're going to be doing a lot of creation of graphs. What I've tried to do for you guys is when it gets to that point is I've given you guys, I can't remember what unit I put that in, but when we get into a lot of the drawing part, I've given you a blank one that you guys can use and print off. So now, here's my question to you. Why would I not put, for example, the number on that side for the negative spot? Why was I putting, I purposely did it, I purposely put, whoopsies, I meant to click that. I purposely put the numbers on this side. Does anyone know why you should avoid putting the numbers not on the other side, particularly with the negatives? Can anyone see what could have happened? Think about how well I write on here, and I did this very carefully. Why would I not put the negatives on that side of it? What would you guys think? Yeah, so what could happen is this is supposed to be a -20. If I don't, I'm going to erase that, and let's say I get quite sloppy and I do that. Can you guys tell that that's a -20? You can't, because I made it so close to that little notch, so that makes it really hard to tell, and that could be a little bit of an issue. So that is why you put it over here, so you can really clearly see that the negative is in front of it. Okay, so try to do that. Everywhere else, it's not such a big deal. You could put it over here, but you might get confused. -30, you shouldn't, but probably your best bet is to put your y-axis one on the left side, just so there's no confusion with the positive or negative. Yeah, you could put brackets around if you need to. Yeah, you don't really see brackets on graphs, so that's not usually a normal technique that people use. They usually just make it clear the other way, but you could. Yeah, you definitely could. All right, so doing that, are we good? Everyone got that written down? Hopefully you guys are okay. Okay, so I have another part here that I want to remind you guys of, and I'm just going to show this here. Actually, I'm going to shrink this down just a bit. Give me 2 seconds. Okay. Okay. So quadrants, that's the other part that I want you guys to note. So please draw that on. So on this, actually, let's go back here. We'll write it in here. So this is quadrant 1. Everything in that quadrant's positive. That's why it's number 1. Okay? And I'm just going to do Q2. I'm not going to write the word each time. You don't have to either. Q2, Q3, and Q4. And Q3 is where all the negatives are. So they're kind of diagonal to each other. All right, and it's counterclockwise. I know it's not normal. Normally we do clockwise when we're doing stuff, but when we're labeling the quadrants, it goes counterclockwise. Okay? All right, so that's just some reminders of the independent-dependent variable. That'll help you when you're going to draw your actual graph, and then understanding how the graph actually lays out. So what we're going to do is we're just going to have a quick little practice of plotting these. So you can use the one that you just drew. You don't have to draw a new one. You can totally use the one that you just drew. And what I want you to do is I want you to plot them. So I'm going to give you guys 30 seconds. Actually, you might have to change your numbers. Actually, I'll give you guys a minute. You might want to draw a new one. And it does not have to be perfect, guys. I'm going to give you guys a minute. Draw a rough new one if you need to, or change the numbers on the number lines to work. And what I want you to do is plot those numbers onto the graph, okay? So I'll give you guys about 1 minute to do that. Go ahead. Okay, so when one of the previous pages of notes that I told you is that in an ordered pair is usually showing x and the y as the coordinates in the ordered pair, and that is a relation. And this is basically the x-axis is what it's talking about, and this is the y-axis. You don't have to write this down. This is just me reminding you, unless you want to, right? So when we look at the point 3 and 7, what that's telling us is that this is the x and this is the y. So I go along the x and find 3, 1, 2, 3, and then I have to go up to 7. So I put my dot there, and just so I know, I label 3 and 7, okay? How many of you guys got that? Put check marks. How many of you guys got that? How many of you guys put that in the right spot? Check it, check it, check, check, what? Okay, perfect. Oh, good. So majority of you guys seem to, let me just go here. Yeah, good. Majority of you guys got that in the right spot. If you didn't get in the right spot, hopefully you can see how that happened there. The next one is -4. So I have to go to the negative side, which is right here, and then up to 3. 1, 2, 3. So this, and it's kind of where they match up. Okay, so I'm basically going, okay, it's along this line somewhere, and then this one, it's along this line somewhere here, and wherever those two lines cross is where that coordinate is. So that would be the -4 and 3. Okay, let's do -7. So -7 is right there, and -2 puts us into quadrant 3. Notice they gave you examples to put into each quadrant. And we have 1, 2, 3, all the way down to -8, that's 7, 6, 7, 8. There we go, down there. And that's 3 and -8. Okay, so you just graphed a relation, the relationship between x and y. So whatever the circumstance is that got the question to be 3 is the x and 7 is the y. So every 3 minutes that I dance, I have 7 blisters, something like that, whatever it is. So that's the relationship, and that's what you're graphing on there. Okay? So hopefully you guys got that all right. Yes, if I had that many blisters, I would definitely stop dancing for sure. Okay. Let's go to this page. Sorry, we're good there? I'm assuming everyone, because you guys had time to do it, hopefully everyone corrected it. All right. So now we're going to start looking a little bit more into domain and range. And what I've provided here for you guys is a couple different ways of showing it. So one way is showing it this way. So we have the x and y, and this guy right here, if I was to write that as an ordered pair, it would show up like this. Okay, so you guys know one way here. The second way is putting it into a table, and the third way is showing it visually like this. So there's 3 ways of showing the relationship between one set and another set. Okay, one is coordinate, one is a table, and then one is showing it like that. And actually the 4th way would be doing an actual graph. That would be technically the 4th way. So what we're looking at here is looking at how they relate to each other. So when we look at the ordered pairs, I'm going to show you, go back here. When you look at the ordered pairs here, there's a whole bunch of numbers, and you kind of, in order to look at all the x's, the first number in each one of those ordered pairs, you have to like move along, and it's not as easy to look at. So then when you look at the table number 2, you can see all of the x's along here, and it's a little bit easier to see them, and then you can see all of the y's down here. So you can see that in x, there is no repeating of any of those values. And if you look at y, you can see that there is a number, -7, that's repeating. So you can actually see that a little easier than if you were looking at the other way that I just showed you. And then the third way, this guy right here, this is showing you another way of writing it. So it's showing you all, in this one here, all of, I'm going to make it green to match. This is all of the x values. We have a -3, we have a -1, we have a 2, we have a 5, and then we have a 7. And all of those are put into here. Why are there arrows? Do you guys know what would be the reason why they have arrows going from this x side over? What does the arrow mean? And then I have all these values. So why would they have an arrow going from -3 over to the 6? To show the relationship. That shows that connection. Remember, it's connected series connected to BC. So -3 is connected to the 6. And so what they've done is basically, in a sort of circular visual, kind of not a Venn diagram way necessarily, but sort of like it, they are showing that 3 is connected or related to 6. Then the next point right here, -1, -7, 2 and 4, 5 and -2. And then we have this guy right here, this last one, 7 and -7. We are actually going to be crossing over. We don't rewrite it. You actually just connect it back to that number. And when you see that, you can tell that you have now literally 2 numbers in the y value that are the exact same, okay? So this was just a way of having you guys show this in a couple different ways. So what I want you guys to do is I want you for B, I just want you guys to make it into the 2 circles, okay? So what I want you guys to do, I'll give you guys 30 seconds, and what I want you to do is make something similar to that using question B numbers, okay? 30 seconds, go. Okay, that was a little quick one. So we're going to look at -3 and 6. So I'm going to put -3 here and put a 6 over here. I am going to then take the -1 and -7, put the -1 connecting to, what did I say, -7. I have 2 and 4, 2 connecting to the 4. I have 5 and -2. And always look to double check that it's not repeated. And 7 and -7, guess what? Up it goes. Okay, so it's the same set of numbers in the image, but I just wanted you guys to get a practice of actually drawing it, okay, just to see how that actually works. All right, so now what we're going to get into is understanding domain and range. So domain is always talking about, this word domain is looking at the x values, and range is looking at the y values. And what we're going to do, so if you said, most of us have heard the word range, you know, home on the range and all that stuff. And if you say somebody ran 5 miles and they ranged from running 5 kilometers an hour to 10 kilometers an hour. So that is showing the span of how much they ran, okay? And so when we're looking at range, that's exactly what it's doing. It's looking at the y coordinate and going, what's the range of the y coordinate? So if we go back to, let's see, what question? Oops, let me find it. This one. If we're looking at the range, we go from 0 all the way up to, what is that? 110? So that's the range of, or what is it, 100, 110, somewhere around there, 105. So that is the range of the distance that they traveled. And then domain, because we can't use range twice, we can't use the word range to talk about two different things or anything like that. Because we have domain is looking at the x values, we went from 0, I'm going to use a different color, we went from 0 all the way to 10. So that was the range of how long that they went, or the domain is how long they went, and then the range is how far they actually went. So that's what domain and range is. And your question is, why does 7 cross? Because it's already written there. So if we look at, who am I talking to? Jess. So if we look Jess here, this is a -7 and that's a -7. So because it is the exact same number in the y spot, you don't write it again. So here, I wouldn't write this, right? I would actually cross from the 7 all the way up to here and show it there because it's already written there. Does that make sense, Jess? Perfect, good. Okay, so looking at these sets of numbers, what I want you to do is tell me what the domain and range is. Okay, what would be the domain? So remember, domain is the numbers that are in the x value, and the range are the numbers in the y value. So what I want you to do is just really quickly, and you just go d equals, I'm going to change my color, d equals, and you always put it into those funny little brackets. Okay, so what would be the numbers that make into the domain, and what would be the numbers that make it into the range? So we are doing the exact same thing that we were doing when we were drawing this stuff. It's the exact same thing, but now we're just showing it in a different way, and we're calling it now domain and range. So instead of saying this is set 1, this is x and y, we're now calling it domain, and we're now calling it range. Okay? So all you have to do with this, guys, is take all the x values. We have -3, we have 0, we have 3, and we have 5. The domain is -3, 0, 3, and 5. That's it, okay? And then the range, you would just do the numbers 6, 3, and -8. Why don't I write this twice? Why don't I write the 6 twice? Why don't I put, I'm going to change the color. Why don't I put another 6 here? Because technically that is one of the numbers in the range. Why am I not writing it twice? So I want you to think back to what happened here. Why am I writing? Yeah, it's already there, exactly. It's already here, so I don't need to be writing it twice. Just like here, this, remember the previous one, this was a -7. And so this guy used a -7, and this guy had a -7 associated with the range. You don't write it twice, you just do it once. Okay, so that is showing the domain is the spans of the information that on the x-axis, and the range is showing the number values data that is used in the y values. Okay, so yeah, so I've showed you like quite a few ways of how you can take information and show it differently for relating it to the x and relating it to the y. So what we're going to get into, this was sort of like a step-by-step. I don't know if you noticed, we went from this and then we changed the wording a little bit more, then we changed the wording a little bit more, and now we are at the spot what I want you to know. I want you to know that we're going to be working with domain and range. All right, you're not going to talk about sets, you're not going to be talking about this stuff here, you're not going to be doing too much of this sort of drawing of the circles and everything like that. It was all step-by-step to get us to this point where we're going to be focusing on being able to write domain and range in this sort of format. Okay, so that was just a little bit of a teaching thing with that. All right, any questions so far, guys? How are we doing? Anything good? Everyone okay? Just want to double check. Good, thanks, Lindsay. Perfect. Okay, everyone else okay? Yes, you. When you write it this way, no. When you write it this format, you're just stating domain and range. That's all you're doing. If you need to see how they're related, it will be written in this format. I won't make you go from I won't make you take domain and range and then try to match them up. You can't do it that way, so, okay? All right, so the next part, I'm going to do a little drawing here. So now we're going to look at something called linear relations. So we're looking at relations. We've been talking about that. Now we're going to look at like the linear relations of them and how they actually look kind of visually. So I want you to draw, we're just going to draw a basic one. We're not going to be doing too much of labeling and making it into like a really nice Cartesian plane. We're not going to be doing that. But I'm changing colors, so a really good idea might be helpful for you to see the difference between the Cartesian plane that you drew and then the actual line that you drew. Might be nice to be using some different colors there so you can see that. This is linear. This is a relation, when we look at the relation and we graph it, so if I go, sorry, I'm just going to move for 1 second. If I take this information right here and I graph it, and it looks like something like this, that is a linear relation, okay? There is another one. We're going to draw another quick one. If we have something that looks like this, this is nonlinear. Okay? So hopefully you can see the difference between those two. Linear obviously is like a line and goes like that. That is nonlinear. We're going to draw one more. And this one is also nonlinear. So I just want to give you guys a couple examples so that you can see which ones are linear and which are not. Okay? So the question is, when you're looking at a set of data, how can you tell if it's going to be linear or it's not going to be linear? So one of the ways you can do that is by looking at the domain and range of it. Yeah, and it's usually typically straight lines, but if you're looking at the numbers, like if we went back here and you looked at the numbers, would you be able to tell if that's linear or not, right? So what we're going to do is sort of have a look at what is that deciding factor of them. So you do not have to write this out, but you might want to, in words, kind of say what's happening here. So what we're doing here is we're showing a relationship between time and temperature, okay? So as time increases, the temperature is decreasing. And what you're noticing is between 0 minutes to 1 minute, it's increasing by 1. From 1 minute to 2 minutes, it's an increase of 1 minute, and so on and so forth. So what we have here is a very consistent increasing of time in the domain, right? In the domain's numbers. Here, we have a consistent decrease every time we go from one value. So 1 minute, as 1 minute passes, we go down 19 degrees. As another minute passes, we go down 19 degrees. And as another minute passes, we go down 19 degrees. This is all consistent. It is constant. Whatever word you want to use, this is how you can tell it's going to be linear, because everything changes at the exact same rate. So if I go up, if I move 1 minute, I go down 19. If I move another minute, I go down 19. Another minute, 19. It's very consistent with what it's talking about. And then if you look over here, this one is non-linear. Why? Why is this one non-linear? So look at the information there. What makes it, what is the key point that's saying that that one is not linear? You can tell right away it is not linear. What about it? So these were the key points. What makes it so that it's not linear in this graph? And again, you guys don't have to draw the graph out. You can just kind of make note of a couple key things that we're talking about. So what makes it so that that one is not linear? Wait. Yeah, so what do you mean, Belle? It's all over the place. It's just all over the place. What does that mean? What do you mean by that? It's all over the place. Yeah, thanks, Caitlin T. It's not consistent. Good. So look at these numbers here, guys. It goes up by 5. If it was consistent and constant, the next one should be plus 5. It's not. It goes up by 10. And then it goes up by 20. So it's not going up by the same number each time. This one here was the temperature, technically it was going down by 15 or 19. this was going up by ones and this was going up by twos. This one isn't. So it's not consistent. It's changing each time. So it's going up by 5 and then it went up by 10. The next one might be up by 30. We don't know, right? Or next 20. We don't know what it is. So it's not very consistent. So that makes sure it's not linear. So when you're looking at data like this, it could be written. It could be like this. It could be 0 and 232. It could be 1 and 213. It could be 2 and 194, so on and so forth. When you're looking at the numbers, you just have to see, is it consistently changing the x, and is it consistently changing the y? And if it is, then it's going to be linear. If it's not, then it's not going to be linear if it's doing some kind of pattern like that. Does that make sense, guys? Hopefully you guys get that. Okay. Is good. Okay. 1 sec. I will give you 1 second. So what I'm going to do now is we're going to have a break with some work. What I want you to do is I'm going to combine both, and I got on the Moodle site, there is an actual little game that you guys get to go play, and then I'm going to give you guys part of the worksheet that I want you to do. That is going to be due at the end as well, but I'm going to give you guys some time to work on it as well, and then we're going to combine the break-in, okay? So Alexis, are we good there? Good, okay. So there are 2 different things on the Moodle site that you guys get to go and play and work on. Don't spend too much time playing on it because you do have work to do, and it is some time for you to focus on that. But there's something called whack-a-mole, and there is something called match the coordinates. So just a little bit of practice of understanding the graph and understanding where a negative is in the x value and the positive is in the y value, what quadrant it is in, and doing it. The whack-a-mole is, I was playing it, and it's super. You have to like get your thinking going, so it might be slow at the start, and you might not actually whack the mole. It's like one of those whack the mole ones, so you might actually miss the mole quite often, but once you kind of get in the groove of it, you'll start figuring it out. And then there's one called match the coordinates. Oh, good. That's awesome. So you have, yeah, so you get to practice, see if you're any faster at all. And then I want you guys to also do some work here. So also on the Moodle site is lesson 1, and I want you guys, this will be needed to be handed in. So question number 1 is saying, says Michael rides up the hill, which graph best represents that? So you're going to look at what you think the story is being told in the graph. So if he's riding up a hill, steep hill on his bike, which one of those graphs best shows that story? And then you're just going to go from there. Number 2 is connected to number 3. So it says it wants you to draw. So 3, this is kind of like saying 2A. This is what it's talking about drawing. You're going to draw the temperature of water in a pot on a stove. It wants you to draw it. Then over here, it wants you to draw the height of the course on your timeline. It wants you to draw that. And then the third one, your height over the lifetime if you smoke. Your health, not your height. That would be weird. And wants you to draw it. So 2 and 3 are connected there. So it's like if you're like, I don't understand what I'm drawing, that's what your drawing is right there. Put a quick definition of dependent, independent variable there. And then I want you to describe the journey. So basically what we did on that first section when I started, describe the journey. There are some blanks to help you out. And then over here is where you tell me, you actually look at what did they actually do on that journey, okay? And then it has a couple questions, and this one gets you to draw it on your own. So I'm not asking in this time period that I'm going to give you guys to have this done, but it's going to be a little bit of a start so that you don't have so much to do at the end. I'll give you some time to do that. Do you make up the information when you draw the graphs? Kind of exactly what we did with the music one where she was turning her music up and down. We just guessed where the volume level is. So what you're going to assume that the corner is 0, 0. And if the temperature of the water in the pot on the stove, what happens when you start at 0, 0? What goes on the bottom? What goes on the y-axis? Where? And then you go from there, and you can do some rough things there. You don't really have to have numbers, but just so we can see the storyline. See here, there is no speed, there is no time written here. There are no numbers of time, there is no speed here, but we can see what's happening to the speed, and we can see how long they're doing each thing. So same thing with this one, okay? So I'm going to give you guys let's do half an hour. I'm going to give you guys half an hour, and I'll give you guys time to have a little break, to play a little bit of the games, do some of the activities, and get started on this. And this shouldn't take you too long to do that. And this does have to get, I know it gets so frustrating, right? You're like, damn, Miss Tim. So it gives you some time to do all that stuff, and then we'll meet back in half an hour, and then we'll continue on with the lesson. All right, so see you guys half an hour. I am available if you need to chat with me or anything like that. So I'll see you guys in half. Okay, bye. did she say? Okay, hi guys. Welcome back. I know one person had to leave because they had an appointment, but hopefully everyone is still with us. Okay. I had a couple of people ask me a couple of questions on the worksheet. Anyone else have a question or anything about what you're supposed to do there? Hopefully it's quite straightforward. How'd you guys do on the mole? How'd you guys do on whack-a-mole? How did that go? Oh, it's quiet. Where's my people? Where are my people? What's happening? What's going on? Can you guys give me check marks? Are you guys there? Oh, I know. How'd you guys do on the whack-a-mole? How'd you guys do on that? Thank you. Good. I know you guys are tired, but I need you guys participating, okay? We gotta do some stuff. I know you mentioned that already. You did good, Alexis? Good. Yeah, you'll get better at it. Your mind will get working a little quicker, so that would be good. All right, perfect. I have an announcement from Mrs. Ward. I am supposed to tell you that Thursday, yeah, I know, you have to like totally figure it out, and then once you get it, you're good. On Thursday, it is optional, but she wants to make sure that you guys know you're invited, and she would love if you could attend. Thursday afternoon, she would like you guys, if you want to join her and go with Mrs. Kelly and her students, to go to the Kelowna Museum. She says if you can meet here at 1:15, and then you guys will go together and you'll be there from 1:30 to 2:30 on Thursday afternoon. So if that is something you're interested in doing, good. If that's something you're interested in doing, please be here for 1:15, and then you guys will all go together for 1:30, okay? So just wanted to make sure that I let you guys know about that. But there's still this class, she said, on Thursday morning with her, but then in the afternoon if you're going to the Kelowna Museum. Perfect, okay. So now what we're going to look at, we were looking at how relations are, what they were. There's that comparison to that. Good. Yeah, she said she's going to send you an email. She just wanted me to mention it to you as well. So now we're going to look at kind of do a tiny little shift. And what I want to do is we're just going to take a little bit of notes about how you can look at now an equation and see if it is linear or nonlinear. So I was showing you how you could look at a graph, and you could see the shape of the graph and decide it's linear, not linear. You can look at the values, the data. You can look at the ordered pairs. You can look at the coordinates. You can look at the little bubble one. You can look at all those things and see if it's linear or not. So what I'm going to do is I'm going to put relations, just so you know it's linear or not linear relations, just in case you guys are confused with what we're doing. Yes, I do, Caitlin. Yeah, I teach. I have grade 8s as well that I teach. Lucky them. Okay, so we have the ones that are linear. So how you can tell it is linear, I'm going to give you guys some examples. Y equals, that's a 4. That's supposed to be a 4. I'm just going to redo that because that's horrible. That's a 4. There we go. X equals -1. Y equals 2x plus 3. 5x plus 6y equals 2. So I'm going to tell you why those are in a second, but I just want you guys to write down some of the examples of equations that are linear, so you can kind of get looking at those and becoming familiar with them. Gave myself some more tea. It's nice and warm. And then we're going to look at which ones are nonlinear. Okay, so nonlinear is y equals 5x squared. X squared plus y squared equals 64. We have x, y equals 3. I don't know, I just collect them, they're fun. If I could, I would have a gazillion cups of all these fun things. I see them like, oh my God, that's awesome. But I have to control myself. It's called control. Okay. And then y equals 7 over x plus 3, and y equals 2 to the power of x. So those are some examples of ones that aren't. And then what I'm going to do here is explain why. Using words. Words. All right. Okay. So, what makes the linear and the not linear ones distinctive? One only has a degree of 1. So if you look at the linear side, nothing has a higher degree than 1. If you look at the nonlinear, there are some that have 2s. Now, I'm not saying that applies to every single one of them, but we're going to kind of show how some of those are eliminated. So right away, we can see that this one isn't linear because of that, and this one isn't linear because of that, and this one has the potential of not being linear because it has the exponent there, but that's going to be a little separate point. Another one, do not, or does not, I should say that. Let me just erase that. I should say does not. Whoa, that erased my G. Does not multiply variables. Okay, so there is, if you look at the linear, there is none of these here that are multiplying the variables together. So there, if you look at this one, there's that one. So that is showing that x and the y are multiplying together. So that's why, even though it's to the degree of 1, now we've gotten to the second point that it's multiplying those variables together, so that doesn't count. Okay? And when you do that, I'm going to show you, I'm just going to do this. I'm going to put example here. I'm going to show this was an example. When you multiply them together like this, remember we did this, oh my gosh, was this back in the polynomial at the very beginning of the polynomial unit? We were asking what degree is this question at? How many degrees is this? How many degrees is this one? Come on guys, I know you're tired. How many degrees is that? Take guesses, I don't care if you're wrong. How many degrees is this? If this is x to the power of 1 and this is y to the power of 1 and we're supposed to determine that equation's degrees. Nice try, thanks Caitlin. Nice try, Caitlin. It's actually going to be 2. This is to the degrees of 2. So when you're looking at determining the degrees on an equation, you put them all together if they're multiplying and stuff like that. Okay, so that would be degrees of 1. If I added like a z to the power of 4, that would be degrees to the power of 6. Okay, because they're multiplying together. So that was a while ago that we did that. I'm just going to see if I can erase that guy again. There we go. Okay. So that is why x to the power, x timesing y, even though they are degrees 1, because they're multiplying, it actually becomes, the equation is fully degrees 2. So that's why that one does not do that. All right. Sorry, Caitlin. Hopefully you get that fixed up. The next one, no variables. Sorry, I didn't leave much space between no and variables. In a denominator. So that is why this one is out. Okay, I'm going to actually point to them so you can kind of see which ones I'm eliminating. So you cannot have a variable in the denominator spot. As soon as you have that, it is not linear. Okay, so that is why you cannot do that. What's blurry, guys? We're doing everything the same, so it might be, I don't know what to tell you about that. Angelina, are you even? Oh, there you are. Okay. I couldn't find you. Yeah, that's right, Caitlin. Nothing's blurry. Okay. And then the last one. So what do you think? This has to refer to this one. This one isn't. So what's the thing probably on this one that makes it not linear? What do you think about this one? Y equals 2 to the power of x. What do you think about that? That would make that one not linear. We can't have what? exponents can't be a variable. Thank you. Good. That's awesome. So no exponents as a variable. Perfect. Okay. So those are all the reasons why you cannot, those are the reasons why those aren't linear, and it's just sort of me showing you a visual way of seeing it and then telling you in words what it is, why those aren't, okay? And the other ones are all good because their exponents are 1, we're not multiplying the variables, there is no variable in the denominator, and there's no variable as an exponent. So that is why. So what I want you to do, I'm going to give you 1 minute. I'm going to give you 6 questions. Actually, I'm going to give you 2 minutes because you're going to have to write the question out and then answer it. I'm going to give you 2 minutes and I'm going to give you 6 questions. And all I want you to do is you just write down the equation. So you write down y equals 2x plus 3 or something, whatever it is. And then you write down linear, not linear. You can put L and L. Doesn't matter to me. This is for you guys. So I'm just going to give those to you and I'll give you 2 minutes to write those down and tell me if they're linear or not linear. Okay, go. Okay, so hopefully it was enough time. If not, you just do as we go. So linear ones, we know that the exponents cannot have, it has to be a 1 exponent. So I'm going to kind of just go through, maybe eliminate. That might have been the strategy I've done to this one. So this, I see there's a 2 exponent, so this one is not linear, okay? And this one has an exponent that is not 1, so this one is not linear. So how you do these questions, there is no set way that you need to do it. So how I would probably do it is just start going through it and eliminating. The next one, they can't be multiplying to each other. Well, this is the L times W times X. This is not linear. Okay. Next one is it can't be in a denominator. None of them have a denominator that has a value in it. And the last one can't have an exponent that is a variable, and none of those have it. So then, technically, the rest should be linear. So this one is a power of 1. There's no variables multiplying each other. Linear. This one here, no variables are multiplying to each other, and they're to the power of 1, no exponents, no denominators, and same with this one. So if you went step by step and looked at each one and looked at number 1 going, okay, is it one of these 4, and then answered that way, that's totally fine. If you did it the way I did it, totally fine as well. So give me a check mark if for a general understanding of the difference between linear and not. Okay. Okay, thank you, Angelina. I was going to say, is there anything I can do to help you? All right, Kaylin, if you guys can all put a check mark or an X indicating how you're doing with this, and then I'll just kind of see what's happening. Jocelyn, what can I do to help you? And Haley. Oh, Jocelyn, you're saying you're good? Okay, Haley, is there something I can do to help you understand the difference? Oh, you're good now. Okay. I don't know if you guys are changing it because you don't want me calling you out or whatever, but hopefully. I can't see the work. Why can't you see the work? I don't know why you can't see it, my dear. It's right there on the screen. What is it that you can't see? If you can just be more specific. I don't know, Angelina, what can't you see? It's so blurry. That might be your connection. It might be how maybe if you've made it too big on your screen. Yeah. Okay, thanks, Haley. Oh, sorry, Hallie. I keep saying your name wrong. I'm so sorry. I know it's my fault. I'm sorry. Sorry. Yeah, it might be just how your resolution, Angelina. It might be how how large you've made it on your screen. I don't know what that would be from. It'll be kind of your own settings, your own computer on that. Okay. Woohoo! So now, that's a relation. Now what we're going to look at is the function part of it. Function junction. We're going to look at that. You can get good vegetables and fruits there. It's in Rutland, up towards Black Mountain. All right. So now we're going to look at functions. And so the difference is a thing is a function. Don't worry about drawing yet. Just kind of go with my writing. If exactly one, that's I'm going to just, yeah, that's exactly. Exactly one. I'm going to put the word element because that is technically the language that we're using in the range. So what that means is there can't be a repeated number in the range. That's what that's basically saying. So when you look at the range, when we did that one where there was 2 -7s, not a function because there's only allowed to be exactly one in the range. Okay, so if we're using that as the definition of function, that there can only be, sorry, that looks horrible, exactly one element or only one number in the range, let's look at this guy. Is this a function? Is this a function? Exactly, because there's more than one in there, okay? And then, oh, sorry. Okay, let me just re-explain. Let's see, how can I make, sorry. Associated, I'm going to add to this, associated with, no, one second. I got to rewrite how to say this. Because how I wrote it, because this one is, okay. Yeah, associated with a x value. Okay, so I'm going to explain this for you. Just write that down, and then I'm going to explain it using these two as an example. Sorry, my wording made that confusing. I just had to add that to it so make it clearer. Okay. So what this means, this guy is. The reason it is because the number 4 has only one answer, 8. Okay? Yes, the number 2 has the answer 8, but the number 2 only has one answer, the number 3 has only one answer, 4, 5, 6, they only have one range answer. So let's look at this one. If I look at the number 1, how many range answers does it have? So how many arrows are coming off of the number 1? Yeah, we have 2 coming off the number 1. Therefore, because of that, this is not a function because this 1 has 2 possible answers for the range or for y, whatever you want to refer it to, because remember this is y and this is x. So when I say it has to have exactly 1, it means it just is associated with just 1. Okay? If you want to reword that into a way that makes more sense to you, you can. I don't want to spend too much time rewording that. But basically it says x value has only exactly one value in the range, okay? So looking over here again, all of these only have one line coming from it. If you look at this one, there's 2 on that one, there's 2 on that one. So right away we know that that is not a function. It is a relation. We're relating the x and the y. There is that connection between the two of them, but it's not a function. Sorry if I confused you a little bit there, but hopefully that makes sense. Is that clear with everybody? We're okay? Did I confuse anybody too much? Did I? Okay. Oh, there we go. All right. So basically, whatever the x value is, it can only have one answer. That's it. One answer. That's it. All right. So let's look at these. I'll give you guys a few seconds to write these numbers down. I want you to write them down. This will be, we can call this one A and this one B. Okay. So what I want you to do is write the numbers down, and then looking at those numbers, if you need to draw it visually, so if you need to, I'm just going to flip, I know you guys are writing, if you need to draw it like this, you can. If not, if you can just look at it like this, you can. Decide if it's a function or not a function. Okay, I'll give you guys a minute so you guys can write that down. Sorry, that was last second. Why would your screen be blurry? That's weird. Doesn't make any sense. Okay, hi. All right, so if you kept it this way, I'm going to show you how you would use this kind of whole number relationship, how you would use this to determine if it is a function. So what I would do is focus just on the x's, because remember, 1x, 1y. So there is -4. Do you see a -4 anywhere else? No. Then we go to 0. Is there another 0 in the x value anywhere? No. 2. Is there a 2 repeated in the x? No. Is there a 7 repeated in the x? No. I love it. Thank you, Caitlin, for replying. 8, no, and 10, no. Therefore, it is a function. Okay? Because each value of x has only one response. So -4, the only answer is -1. That's it. So then let's go over here. We have a -1 here. Do we have -1 anywhere else? Boom, we do. So as soon as we have that, it's not a function. You take it, kick it to the curb, say, see ya later, you're not a function. Okay? But it is a relation. All right? So yeah. Now I'm going to show you another way of determining if it is a function or not. So, and it's called the vertical line test. So this one is the vertical line test, and what you do is basically, because there can only be one value, only one dot on the x line, then as soon as you see that there's more, can I go back? Yes, I can. As soon as you start seeing that there's another dot on the x, because that's what this is, right? Remember that this is the x. So here, that would mean, if I did this, I'm going to show you here, this would be -1 and -4, and this would be -1 and -1. So I have two numbers on this x line of -1. So that's what that means. So visually, what we're looking for, you good, Caitlin T? Yeah, good. So now what we're looking for is making sure that if we go along the x-axis like this, that there is only literally one number on that line, okay? So that's called the vertical line test. So I don't know if you just in words say, let's do that. Let's do some words, because I don't really want you guys drawing this out. You don't really have to draw this out. You can say only one coordinate on, wow, I don't know what I did there. Only one coordinate on the x line. X line, something like that, equals vertical line test. That's sort of just putting what I just said and what we're visually going to see into words. Okay, so graph A, what we're going to do is we're going to go along, and I'm going to do this very shakily. There's only one spot there. I'm going to go down this line. Wow. There's only one spot there. I'm going to go down, where's my next line? There's that one. Okay, I just hit 2 dots. Therefore, nope. That's not a function. So that's the vertical line test. All I did was go across and try to see if it works. So let's look at this one. Go down, there's 1 point. Go down, there's 1 point. Go down, there's 1. Go down, there's 1. And go down, there's 1. So this one, yep, that is. Good. So do you have to draw lines like I just did? No, but that's just me showing you what. So you can just visually with your eyes go, is there any another dot on that x value line? If there isn't, then you're good to go. Okay. Can I leave this page? I didn't, like I said, I didn't care. If you want to draw it, you totally can draw it. Maybe take a picture. You can quickly redraw it later. But am I good to move on? We're almost done here. We got 2 more things here. Okay. So what I want you to do is look at this and decide if it's a function or not. Okay. So if we look at this guy and we draw lines going down, is there a spot where there's going to be technically 2 sort of dots or parts of the line on there? Is there a spot that it doubles up at all? So you guys are saying yes. Where would it double up? Where do you guys think that it actually doubles up? On the first part where it goes up. So it's actually, believe it or not, it's kind of technically going like that. This one is a function. It looks like it's not, but it never stays on the same spot. If it stayed on the same spot, it would be going straight down. And if you notice the angle of this line, it is going at a slight diagonal. And because it is going on a slight diagonal, like this point might be -6 and -5. The next one might be -6.1 and -5.1. But it is going on a slight angle, and because it's going on that slight angle, it's not hitting that same spot. It would have to be literally going straight up and down in order for it to do that. What about the next one? Does the next one have, is it a function or not a function? What do you guys think? So again, looking at the slight angle, does it actually hit twice on one spot on the x? Good. It does not. So that one is a function. Now this one. So I want to just point this out to you. You guys notice that these guys have arrows. Well, it did. I crossed it out with the green. It has arrows at the end. What does that mean the line's doing? If there's arrows at the end of the line, what does that mean it's doing? It's going on forever. Yeah, so it keeps going. When we have this, what does it mean here? What does it mean when there is the dots right there? It's not arrows. What does it mean? Yeah, infinite line. Good, thanks, Belle. Yeah, it ends. It has endpoints, right? This one here, the graph does keep, this line, those 2 lines do keep going on, but let's look at what's happening right here. So if you notice, they are not actually overlapping. So thanks to Merle for zooming in. You can really see it a lot better here. You can see that this guy right here is actually not on the same line as this guy is. So they are not overlapping. There is no overlap. So they kind of gave you a little bit of a hint at the bottom here where they said this one is probably 0.99999 and this one has a lot more 9s after it. So they're super, super close, but they actually don't intersect. And the big hint is because if they did intersect, it would probably be a continuous line, but it's not. You can tell that it's not a continuous line because they're actually showing endpoints. And once they do that, you know that they're not stopping and starting on the same spot, or else they would have just done something like that. Okay? So that's using the vertical line test and also understanding how the graph works and kind of the slight diagonals. Yeah, they're a little bit more than 0.5 off. I think they're probably a lot closer than that, just not really showing. Okay, and then this guy, vertical line test. Really quickly, you guys figure it out on your own. Don't type the answers in. Look at A, look at B, and look at C, and decide, is it a function? Is it not a function? Using the vertical line test. Okay, and I'm going to ask people that never participate or rarely participate. Let's ask Alex. Alex, you can pick whichever one you want. You can say A, B, or C. Tell me one of them and tell me if you think it is a function or not a function. So I don't care which one you pick, just let me know which one. I know, Belle, I never hear you. You never speak to me ever. A is a function. So let's look at A. So what I would do is do like the vertical line test and look what happens when I go here. So Alex, I love this. Your brain is going to grow. So if I did the vertical line test going down here in my shakiness, do I have 2 spots that hit there? Do I have 2 spots that hit here? So guess what? This one is not a function because there's many spots along the way that if I did the vertical line test, that it hits twice. So perfect, Alex. That's awesome. Now you know. So that's great. Who wants to do, let's see, I'm going to pick someone else. Let's do Josh. Josh, B or C? Which one do you want to try? What do you want to try, B or C? That's why you and I are friends, Caitlin. Josh, are you there, Josh? There we are. Good. So B or C, which one do you want to do? And then tell me if you think it's a function. B is a function. So if I go across, and again, these are going on angles, right? If you see this, they're going on angles, and because of that, they're not going straight up and down. So yes, it is a function. Good. So it's never crossing. If I did a vertical line test, it would not cross twice. And let's do Dylan. Dylan. Can you please tell us about C? Do you think C is a function or not a function? What do you think? I'll do a different color again. I'll do red this time. What do you think, Dylan? Is it a function or not a function? He's typing. I see he's typing. You think it's not a function. Perfect. So let's look at this. And Merle, if you can zoom in like you have been, which is awesome. So let's look. We're going to go down this line. Does anyone know what that open circle means? What does that, I can highlight that. What do these open circles actually mean? Nice try. Thanks, Alexis. Thanks, Emily. What is that open? What's the difference between the open circle and a closed circle? There has to be a difference or else they would use the same thing. So what would be the difference between an open and a closed circle? Wager a guess, anybody? Anybody? What it means is that, you guys are all kind of dancing around it. It means it does not include that spot. It literally, so what spot would that be? That's 2. That means it stops probably right before it. So it probably goes to like that other question, 1.99999. What it means is that it's stopping right before that. This guy here actually includes 2. So what this means is if I did the vertical line test going down, there is no overlap because this guy stops right in front of it and this guy starts right on it. So there is no overlap. So technically, this one is a function because there is no overlap because of the open circle and closed circle. That was a tricky one. Good. Thank you, Dylan, for answering that one. I appreciate that. All right. So, does everyone get that? We get? Okay. We're done. So what I'm going to do is just go over a couple things with you guys here first. So, you have to finish this one. This has to get handed in as well. So the one that you guys, hopefully you guys got that done, not too much time. Hopefully you got that done. This guy is practice. Actually, you know what? I don't even know if I put that on there. I don't even know if I put that on there. If there's one on there, I can't even remember my Moodle site. Actually, let's go look over. And I'm in the wrong unit. Here we go. Yeah, there's one for practice. So there's just that one that you guys can do for practice. Thank you. Thanks, guys, for noticing that. And then you have to do this one and you have to hand that one in. So there's two that I want you to hand in. One focuses more on lesson, like the first part of the lesson, and the other one focuses on the second part of the lesson. So we've kind of done two lessons into one day. Like I said, this is going to go pretty quickly. So, so one practice, do as much as you want, as little as you want, it's up to you. And then you have two that you have to hand in. So I'm going to go back to this, and 2 seconds, there's always so many buttons to push. All right, so you have a test this week, reminders, okay, closed book, don't have any materials with you, someone has to supervise, no phone, you're allowed to use a calculator, all your work has to be done for the trig unit, okay? And the trig unit is now this term, so this is all starting fresh, okay? You need to do it from today to Friday, so get that done as soon as you can. Have confidence, okay? You might feel like a kitten, but look at yourself in the mirror and make sure you feel like a lion when you go in there. Strong, confident, proud, okay? And make sure you have that positive attitude going in, positive attitude as you're studying, so that your brain is getting used to that pathway, all right? So just reminders, you got to do that, because I know we always it's easy to go down that path and think that negative thought, but try to make those positive thoughts come. So, I have to make sure your test is due on Friday, make sure all your old work is done, you have a practice worksheet to do, 2 to hand in for Wednesday, and make sure you smile. So that is it. And just remember, if you're planning on coming on Thursday for Mrs. Ward and the Colonial Museum, it's 1:15, and I think that's all I have to tell you. So any last minute questions or anything from you folks? Oh, you guys. Got a couple people. Yes, there is Math Health. Yeah, yeah, you betcha. All right, so I will be having my lunch here soon, but I will be available to respond to any of your questions you guys have at that point. But if you are good, you're welcome to go, and I'll see you guys on Wednesday. You're welcome, Caitlin. See you later. Welcome, Belcia. Bye, Dean. Bye, Dylan. Bye, bye, Jess. Bye, Bryn. Bye, Em. Bye, Alex. Bye, Josh. I feel a little scattered with this year because I didn't finish grade 9. That's okay. This stuff is kind of newish. It's kind of newish, and a lot of the stuff was prior to that. Some of the stuff I taught you guys in grade 7, so some of it's there. Yeah, you bet. I can help you with anything you need, Alexis. If just send me messages. See you later. Jocelyn and Lindsay, are you guys good? All right, I'm going to say goodbye. You guys can send me messages if you need to on Moodle. Bye, everybody.